MIT OpenCourseWare. We are back on the stream. What is going on, all the people? What is going on with thee? All right. What the dog doing? Okay, let's get this thing loaded up for today, yeah? Take off my badge. Social stream. Break me out for piece of that good bar. Whoops. First chatter is me. First chatter is me. Woo! All right. All right, you guys, what's going on? Welcome back into the stream today. I hope you're having a wonderful day so far. My name is Michael, as you know. Today is August 14th, 2025, and we are going to be back again doing some programming like usual. Nothing new here. All right, you guys, we are going to be taking the opportunity today to jump back into MIT 6.0002 OpenCourseWare, or OpenCourseWare 6.0002, which is the Introduction to Computational Thinking and Data Science course offered by MIT. We're going to be moving on and watching the next lecture today, which is lecture number 7 on confidence intervals, which is kind of getting into more statistical-based programming and things along those lines. So I appreciate you guys being here and joining me today. Welcome one, welcome all. We are going to be getting into this bad boy shortly here. Let's allow some people to roll in the chat, and we'll get started here. Okay, we'll let people get in here and then we'll get started here. If you guys are new here, or welcome in. I appreciate you guys joining me. We are going to be watching Introduction to Computational Thinking and Data Science, Lecture 7, Confidence Intervals. This one's going to be by our Mr. friend, I believe it's by Professor Guttag again. John? Yes, John Guttag is going to be teaching us this one. What's going on, everybody? Let's go ahead and turn off the tunes and we'll go ahead and get started here. Might as well. No time but now. Let's get into it. Turn off the tunes. All right, cool. Let's go ahead and get into this today. I'm excited. All right, you guys. Let me go ahead and start the recording. Hello everybody, welcome back to the channel. Hope you're having a wonderful day so far. My name is Michael. Today we are jumping back into MIT OpenCourseWare 6.0002 Introduction to Computational Thinking and Data Science. fall 2016. This is Lecture 7, Confidence Intervals. If you guys would like to watch this alongside me live on stream, I stream every single day around 7 p.m. PST as I teach myself computer science and programming, more specifically that in Python for the moment. So thank you guys so much for being here, and I appreciate you guys so much. So let's go ahead and get started. You can catch all the lectures that I previously watched on my streams or that are uploaded in condensed versions up to the channel. So let's go ahead and start lecture 7 here. Let me know how the audio is, you guys, and hello, hello, hello. Let's roll.
EDU.
Hi, everybody. Welcome back to class.
Welcome back to class, John.
I have a lot to cover today, so I'm just going to get right to it. So you may remember at the end of last lecture, I talked about the empirical rule and said that there were a couple of assumptions underlying it. That one is that the mean estimation error is 0, and second, that the distribution of errors will be normally distributed. I didn't probably mention at the time, but we often call this distribution Gaussian, after the astronomer Carl Gauss. And it looks like that. Normal distributions are very easy to generate in Python. I have a little example here of generating not a real normal distribution, but a discrete approximation of one.
Gotcha.
2016. And the thing to really notice about it here is this line, random.Gauss.
What's going on, Ark? What's going on, dude?
So that's a built-in function of the random library. The first argument is the mean, and the second argument is the standard deviation, or mu and sigma, as they're usually called.
Sigma?
Every time I call that, I will get a different, or usually a different random value, drawn from a Gaussian with a mean, in this case of 0, and a standard deviation of 100. I'm then going to produce a plot of those so you can see what it looks like. And I'm going to do that using some things we haven't seen before.
Okay.
So first of all, we've seen histograms. So pylab.hist produces a histogram.
Yeah, so
bins tells us how many bins we want in the histogram. I said we want 100.
100
the
bins.
default is 10. Dist is the values it will use for it. And then this is something we haven't seen before.
Weights.
Weights. Weights is a keyword argument. So normally when we produce a histogram, we take all of the values, the minimum to the maximum, and in this case we would divide them into 100 bins, because I said bins equals 100.
Gotcha.
And then we would, so the first bin might be, well, let's say we only had values ranging from 0 to 100. The first bin would be all the zeros, all the ones, up to all the 99s.
Okay.
And it weights each value in the bin by 1. So if the bin had 10 values falling in it, the y-axis would be at 10. If the bin had 50 values falling in it, the y-axis would go up to 50. You can tell it how much you want to weight each bin, the elements in the bins, and say, no, I don't want them each to count as 1. I want them to count as a half or a quarter. And that will change the y-axis. So that's what I've done here. What I've said is I've created a list, and I want to say for each of the bins, in this case I'm going to give them, weight each of them the same way. The weight is going to be 1 over the number of samples. I'm multiplying it by the len of dist. That will be how many items I have, and that will tell me how much each one is being weighted. So for example, if I have, say, 1,000 items.
Okay, 1,000 items.
I could give 1,000 values and say I want this item weighted by 1, and I want this item over here weighted by 12 or a half. We rarely do that. Usually what we want is to give each item the same weight. So why would I want it not to be weighted at just 1? Because I want my y-axis to be more easily interpreted as essentially giving me the fraction of the values that fell in that bin. And that's what I'm doing here. The other new thing I'm doing here,
I don't know if he's doing a great job explaining this,
is the plotting commands, including pylab.hist, many of them return values. Usually I just ignore that value and we just say pylab.plot or pylab.hist. Here I'm taking the value. The value in this case for a histogram is a tuple of length 2. The first element is a list or an array giving me how many items are in each bin. And the second is the patches used to produce the beautiful pictures we're used to seeing. So here what I'm going to do is take this value so that I can do this at the end.
For a fraction within about 200 of mean.
Now why would I want to look at the fraction within approximately 200
the return value
of mean?
from the histogram?
What is that going to correspond to in
index
this
30
case?
through 70. Slice 30 through 70.
Well, if I divide 200 by 2, I get 100.
The sum of the list,
which happens to be the
and the
standard
tuple,
deviation.
right? The first item in the tuple.
So in this case, what I'm going to be looking at is what fraction of the values
so within 20 of the
fall
mean,
within
basically.
2 standard deviations of the mean.
2 standard deviations.
Kind of a check
20,
on the
like,
empirical rule, right?
If you have 100 values, right?
All right. When I run the code, I get this. So it is a discrete approximation to the probability density function. You'll notice, unlike the previous picture I showed you, which was nice and smooth, this is jaggedy. You would expect it to be. And again, you can see it's very nice that the peak is what we said the mean should be, 0, and then it falls off, and indeed, slightly more than 95% fall within 2 standard deviations of the mean. Not even surprised that it's a little bit more than 95% because, remember, the magic number is 1.96, not 2. But since this is only a finite sample, I only want it to be around 95. I'm not going to worry too much whether it's bigger or smaller. All right? So random.gauss does a nice job of giving us Gaussian values. We plotted them. And now you can see that I've got the relative frequency. That's why I see fractions on the y-axis rather than counts. And that was because of the way I used the weights command. All right, let's return to PDFs. So as we said last time, distributions can be defined by probability density functions. That gives us the probability of some random variable lying between 2 values.
Distribution is defined by probability.
It defines a curve where the values in the x-axis lie between the minimum and maximum values of the variable. And it's the area under the curve, and we'll come back to this, between those 2 points that give us the probability of an example falling in that range. So now let's look at it for a normal distribution. You may recall from the last lecture this rather exotic-looking formula, which defines a PDF for a normal distribution. And here's some code that's as straightforward an implementation as one could imagine of this formula. Okay, so that now is a value that, given a mu and a sigma and an x, gives me the x associated with that mu and sigma. Okay? And you'll notice there's nothing random about this.
So probability density function for a normal distribution.
Now, let's go down here
Basically just the function to build
And I'm going to, for a set of x's, get the set of
And it's just
y's
showing you how to do it in
corresponding to
Python.
that, and then plot it.
We've done something similar
I'm going
in
to set
our
mu to
projects.
0 and sigma to 1, a so-called standard normal distribution. And I'm going to look at the distribution from -4 to 4. Nothing magic about that other than, as you'll see, it's kind of a place where it asymptotes near 0. So while x is less than 4, I'll get the x value. I'll get the y value corresponding to that x by calling Gaussian, increment x by 0.05, and do that until I'm done.
Until you hit 4.
And then simply I'll plot the x values against the y values and throw a title on it using pylab.title. All right, does code make sense?
Mm-hmm.
Well, this is where I got that beautiful picture we've looked at before. When I plot it here,
Immortal,
it
yo, what's going on?
looks actually quite smooth.
Yeah.
It's not. It's really connecting a bunch of tiny little lines, but I made the points close enough together that it looks, at least here, smooth at this resolution. So we know what the values are on the x-axis are. Those are the values I happen to want to look at, from -4 to 4. What are the values on the y-axis?
The factor that was given, no? From the Gaussian?
We kind of would like to interpret them as probabilities, right? But we could be pretty suspicious about that. And that if we take this one point that's up here, we say the probability of that single point is 0.4. Well, that doesn't make any sense. Because in fact, we know the probability of any particular point is 0 in some sense, right? So furthermore, if I chose a different value for sigma, I can actually get this to go bigger than 1 on the y-axis. So if you take sigma to be, say, 0.1, I think the y-axis goes up to something like 40.
Mm-hmm. Yeah, we've done that
So
before.
we know we don't have probabilities
And
in the range
spectrosim.
40.
We've manipulated
So
sigma.
if these
and
aren't probabilities, what are they? What are the y values?
Mm-hmm.
Well, not too surprising, since I claimed this was a probability density function. They're densities. Well, what's a density? If this makes sense, I'll say it, and then I'll try and explain it.
Derivative of
It's a
cumulative
derivative
distribution.
of the cumulative distribution function. Now, why are we talking about derivatives in the first place? Well, remember what we're trying to say. If we want to say, ask what's the probability of a value falling between here and here, we claim that that was going to be the area under this curve.
Mm-hmm.
Right?
Yes.
The integral. Well, as you know from 1801, there's a very clear relationship between derivatives and integrals. And so if we interpret each of these points as a derivative, in some sense the slope here, then we can look at this as the area just by integrating under there. So to interpret a PDF, we always do it mathematically. Actually, I do it just by looking at it. But the only really interesting mathematical questions to ask have to do with area.
Interesting.
Once we have the area, we can then talk about the probabilities.
Of something falling
Of
within the
some
area. Yeah, I remember that
value
from my
falling within a
statistics
region of the
class.
curve.
Stats 3000,
What's
baby.
interesting here is not the numbers per se on the y-axis, but the shape of the curve. Because those numbers have to be related to the numbers on the x-axis. dx, dy, right? We're looking at derivatives. All right, so now we have to talk about integration. I promise you only hear about it for another few minutes, then we'll leave the topic. So I mentioned before SciPy as a library that contains a lot of useful mathematical functions.
SciPy library is useful mathematical functions.
One of
for
them
scientists and
is
engineers. SciPy
integrate.quad.
integrate.quad has up to 4 args.
the integrate part is obvious. It means
A function or
integration.
method to be integrated.
Quad is telling you the algorithm it's using to do the integration. All of these integrals are going to be actual approximations to the real integral. PyLab is, or SciPy is not doing some clever mathematics to get an analytical solution. It's using a numerical technique to approximate the integral. And the one that's used here happens to be called quadrature. It doesn't matter. All right, you can pass it up to 4 arguments.
Gotcha.
You must pass it the function to be integrated. That makes sense. A number representing the lower limit of the integration, you need to give it that. A number representing the upper limit, you need to give it that. And then the 4th argument is a tuple supplying all values for the arguments to be except the first of the function you're integrating. I'll show you an example of that on the next slide. And we'll see that it returns a tuple, an approximation
how's it going?
to
How's it
the
going?
result,
Thanks
what
for coming
it
in.
thinks the integral is, and an estimate of how much error there might be in that one. We'll ignore the error for the moment. All right, let's look at the code.
Okay, let's look at
So we
it.
start by
Importing SciPy integrate.
integrate.
Okay. We establish a Gaussian function with
That
an x
gives us
value,
all the
a
different
mean,
integration methods.
and a standard
I'm not
deviation.
going to show you the code for Gaussian since I showed it to you a couple of minutes ago.
Yeah.
But I wanted you to remember that it takes 3 arguments, x, mu, and sigma. Because when we get down here to the integration, we'll pass it the function Gaussian,
So Gaussian will be our function.
and then the
that's
values that we want to integrate over.
So our lower bound, our upper bound.
So those will be the values that
So
x can take upon.
Sigma minus this.
And that will change as we go from mu minus the number of standard
the mean
deviations
minus this
times
number of
sigma
standard
du
deviations.
plus the number of standard deviations times sigma. And then this is the optional 4th argument, the tuple mu and sigma. Why do I need to pass that in? Because Gaussian is a ternary argument, or function. It takes 3 values. And I'm going to integrate over values of x, so I have to fix mu and sigma to constants, which is what I'm doing down here. And then I'll take the 0th value, which is its estimate of the integral. All right, so that's the new thing. The rest of the code is all stuff you've seen. For t in ranged number of trials, I'm going to choose a random
For every
mu
try, we're going to choose a
between
random
minus 10 and 10, and a random
mu
sigma
and a random
between
sigma
1 and
between
10.
1 and 10.
Doesn't matter what those constants are. And then
Just print them.
for the number of standard deviations in 1, 1.96, and 3, I'm going to integrate Gaussian over that range.
Okay.
And then we're just going to see how many of them fall within that range. In some sense, what we're doing is we're checking the empirical rule. We're saying, take a Gaussian,
Yo,
I don't
Ray.
care what mu and sigma are, doesn't
Everybody
matter.
chill, Ray's here.
The empirical rule will still hold, I think. But we're just checking it here.
Must be hot in there. Gutago's got
Okay.
some pits, so that's going on. I feel you, brother.
Well, here are the results.
Okay, for
So
a
for
mu of
equals
9 is
9
sigma.
and sigma equals 6, happen to choose those. We'll see the fraction within 1.
So about over a little over half.
1.96 and 3. And so for these random mu's and sigmas, you can see
They
that
come out
all of them,
pretty
you can
similar.
set them to whatever you want when you get your hands on the code. Essentially what we have is, whoops,
They're all the same values.
the empirical rule actually works. One of those beautiful cases where you can test the theory and see that the theory really is sound. So there we go.
What the sigma low?
Why am I
No.
making such a big deal of normal distributions?
Don't start this. No,
They have
no.
lots of nice mathematical properties, some of which we've already talked about, but all of that would be irrelevant if we didn't see them. The good news is they're all over the place. I've just taken a few here. Up here, we'll see SAT scores. I would never show that to high school students, or GREs to you guys. But you can see that they're amazingly
MIT students looking at these SAT scores being like, we're all the way up. We're up here, boy. We're these guys. MIT students.
This is plotting
laughing right
percent
now
change in oil prices.
at the average.
And again, we see something very close to a normal distribution. And here is just looking at heights of men and women. And again, they clearly look very normal. So it's really quite impressive.
But not
how
all
often they occur.
distributions are normal here. So these are just like
But
occurring naturally.
Not everything is normal. So we saw that the empirical rule works for normal distributions. I won't say I proved it for you. I illustrated it for you with a bunch of examples.
Distributions. The outcomes of spins of a roulette
But
are
are the
normally
outcomes
distributed?
of the spins of a roulette wheel normal?
No, not each one has the same
No.
weight, you know?
They're totally uniform, right? Everything is equally probable.
Or sorry,
4,
equally
6,
probable, I mean,
11,
sorry.
13,
There
double
isn't like
zero
a
if you're in
more
Las
highly
Vegas.
likely
They're all equally probable.
middle mu.
So if I plotted those, I'd basically just get a straight line with everything at 1 over however many pockets there are.
Yeah.
So in that case, why does the empirical rule work? We saw that we were doing some estimates about returns, and we used the empirical rule, we checked it, and by
Tim,
George,
yo, welcome back,
it
Tim.
was telling us the truth.
About time you showed up, Tim.
And the
This is
reason
getting interesting. This is getting
is
interesting
because
here.
we're not reasoning about a single spin of the wheel, but about the mean of a set of spins. So if you think about it, what we were reasoning about was
Not
the
just
return
one
of
spin and
betting.
the probability of a single, but
we look
the
at one
bet over
spin-
the course of a night.
Well, let's say we bet $1.
And
The
just so
return is
happened
either
that night you
-1
maybe
because we've lost our dollar,
got like
or if
more.
we get lucky and our pocket happens to come
Why
up,
is it normal?
it was 36, I think, or 35, I forget which. Okay, but that's all. So if we plotted a histogram, we would see a huge peak at -1
Huge peak.
and a little bump here at
Pause.
36 and nothing in the middle. Clearly not a normal distribution.
No.
But what we're reasoning about
This is getting interesting
not
now. Here we go.
the return of a single spin, but the return of many spins. If we played 1,000 spins, what is our expected return? As soon as we end up reasoning not about a single event, but about the mean of something, we can apply something called the central limit theorem.
Central limit
Here it
theorem.
is.
Given a system
It's
of
actually,
sample,
for something so important,
the means of the
very
sample and a
simple.
set of sample.
It says that given a sufficiently large sample, and I love terms like
The means
sufficiently
of the
large,
samples and a set of samples.
but we'll later put a little meat on
The
that.
average of the
The
samples
following three things
will
are true.
approximately normally distributed.
The means of the samples in a set of samples, the so-called sample means, will be approximately normally distributed. So that says if I take
Huh.
a sample,
Take a
and
bunch
remember,
of rolls in
sample
a
might
night.
will have multiple examples. So just to remind people,
So let's just say we're at the casino all night long. We're being a degen like Tim.
population is a set of examples. A sample is a subset
of
of the population.
Yeah.
So it too is a set of
Sam-
examples.
A set of
right?
examples in its own. But then
Typically.
you have a
If this set is sufficiently large,
you can relate it back to the population.
certainly one is not sufficiently large, then it will be the case that the mean of the means, so I take the mean of each sample, and then I can now plot all of those means, or take the mean of those, right?
Yeah.
and they'll be normally distributed. Furthermore, this distribution will have a mean that is close to the mean of the population.
Yeah, that's what we said earlier. Bingo.
The mean
I
of
remember
the means will be
Stat
close to the mean of
3000
the
back
population.
6 years
And the
ago.
variance
I remember.
of the sample means will be close to the variance of the population divided by the sample size.
The variance of the sample
This
means
is
will be close
really
to the variance
amazing that this
by
is
the
true.
sample size
And
of this subset. of the
dramatically
population.
useful.
Gotcha. Right. It's factored by the sample size.
So to get some insight, let's check it. To do that, postulate that we have this kind of miraculous die. So
Okay.
instead of a die
Got a
that when you
dice.
roll it, you get a number 1, 2, 3, 4, 5, or 6, this particular die is continuous. It gives you a real number between 0 and 5, or maybe it's between 1 and 6. Okay?
Where is it? Range of...
So it's a continuous die. What we're going to do is roll it a lot of times. We're going to say how many die, and then how many times are we going to roll that number of die. So the number of die will be the sample size. Number of dice will be the sample size. And then we'll take a bunch of samples, which I'm calling number of rolls. And then we'll plot it.
Okay,
and
so
I'm
like
just
either
saying
2 dice that you
using
roll
some
5
bins
times,
and
or
some
5
colors
dice
and
that you
some
roll
style
6
and
times.
various
Gotcha.
other things, just to show you how we use the keyword
Yahtzee.
arguments. So for
So we're going to gather all the
actually, I said
means.
num rolls is the number of trials, but it isn't quite that. Because I'm going to get the number of trials by dividing the number of rolls by the number of dice. So if I have more dice, I get to have fewer samples, more dice per sample.
Okay.
All right?
So if you have fewer dice, you
Then
roll
we'll
more
just
times.
do it. So
Gotcha.
it will be between 0 and 5, because random.random returns a number between 0 and 1.
And we're going to do
I'm
that
multiplying
5.
it by 5.
Multiply that by 5.
And then we'll look at the means, and we'll plot it all. Again, we're playing games with weights just to make the plot a little easier to read. And here's what we get. If we roll 1 die, the mean is very close to 2.5. Well, that's certainly what you'd expect, right? It's some random number between 0 and 5.
Well, it's
2.5
probably in the
is
middle,
a pretty
is a
good
pretty
guess
good
as to
guess
what
of the
it should
average,
average.
Yeah.
And it has a standard deviation of 1.44. That's a little harder to guess that that's what it would be, but
It's
you can
pretty
figure
high
it out
because you
with
have,
math
you know,
or
low number
as I
of
did
dice
here with the
rolls for
simulation.
1 die. So
But
it's
now if
pretty
I
high.
roll 50 dice,
Okay, so now you
well,
have more
again,
confidence.
the mean is close to 2.5. That's what you'd expect, right?
Standard deviation is a lot
I roll
lower.
50 dice, I get the mean value of those 50. But look how much smaller the standard deviation is. More
Hey,
importantly,
Ozzy, how's it going?
what we see here is
We
that
started learning programming about a year ago.
if we look at the value, the probability is flat for all possible values between 0 and 5 for a single die. But if we look at the distribution for the means, it's not quite Gaussian, but it's pretty close. Why is it not Gaussian? Well, I didn't do it an infinite number of times. Did it quite a few, but not an infinite number. Enough that you didn't want to sit here while it ran.
So one
But you
dice
can see
would
the
be-
amazing thing here that when I go from looking at 1 to looking at the mean of 50, suddenly I have a normal distribution. And that means that I can bring to bear on the problem the central limit theorem. We can try it for roulette. Again, I'm not going to make you sit through a million trials of 200 spins each.
Okay.
I'll do it only for fair roulette. And again, this is a very simple simulation.
For the number of trials
we'll
we're
see
going
what
to
we
do,
get.
we're going to...
And what we see is it's not quite
Skewed
normal
left.
again, but it definitely has that shape. Now, it's going to be a little bit strange because I
Yeah,
can't
well, Ozzy, we'd
lose
be
more
leveling
than
up,
one,
yeah. Isn't that
right?
crazy?
If I'm betting one.
A script?
So it will never be quite normal, right? Because it's going to be truncated down on the left side. Whereas the tail can be arbitrarily long.
Mm-hmm.
So again, mathematically it can't be normal, but it's close enough in the main region where most of the values lie that we can get away with applying the empirical rule and looking at answers. And indeed, as we saw, it does work. So what's the moral here?
Doesn't matter what the shape of the distribution or values happen to be.
It doesn't matter what the shape of the distribution of the original values happen to be.
If we're trying to estimate the
If
mean
we're
of a
trying to
population
estimate the mean
using sufficiently large
using samples that are sufficiently large,
the central limit theorem
the
allows us to
CLT
use
will allow us to use the empirical rule
when computing confidence
when
intervals.
computing confidence intervals.
Okay.
Even if we go back and look at this
Like we know what's
anomaly
going on.
over in the left, what do you think would happen if I, instead of had 200, had, say, 1,000?
It might be a little bit more centered.
What's the probability of the average return being -1 of 1,000 bets? Much smaller, right, than for 100 bets.
Mm-hmm.
To lose 1,000 times in a row is pretty unlikely. So to get all the way to the left is going to be less likely, and therefore the thing will start looking more and more normal as the samples get bigger. All right. And so we can use the CLT to justify using the empirical rule when we compute confidence intervals. All right, I want to look at one more example in detail. This is kind of an interesting one. You might think that randomness is of no use for, say, finding the value of pi, because there's nothing random about that. Similarly, you might think that randomness was of no use in integrating a function. But in fact, the way those numerical algorithms work is they use randomness. What you're about to see is that randomness, and indeed things related to Monte Carlo simulations, can be enormously useful even when you're computing something that is inherently not random, like the value at pi here. And we won't ask you to remember that many digits on the quiz, in the exam. All right, so what's pi? Well, people have known about pi for thousands and thousands of years. And what people knew was that there was some constant, we'll call it pi, it wasn't always called that.
I didn't know this.
Such that it was equal to the circumference of a circle divided by the diameter. And furthermore, the area was going to be pi r squared. People knew that way back to the Babylonians and the Egyptians. What they didn't know is what that value was. The earliest known estimate of pi was by the Egyptians on something called the Rhind papyrus, pictured here.
That's crazy.
And they estimated pi to be 4 times 8/9 squared, or 3.16. Not so bad.
Wow. That's nuts.
About 1,100 years later, an estimate of pi appeared in the Bible, King 723. Didn't say pi is, but it described, I think this was a construction of King Solomon's temple. He made a molten sea 10 cubits from one brim to the other. It was round, i.e. it was a circle. His height was 5 cubits, and a line of 30 cubits did compass it round about. Well, if you do the arithmetic, what does this imply the value of pi to be? 3. And I'm sure that's what Mike Pence thinks it is.
Bruh.
About
Why is
300 years later,
Prof. Gutak throwing shots? Boom, boom, boom,
Archimedes
boom.
did a better job of it.
Tim.
He estimated pi by constructing a 96-sided polygon.
We know.
There's a picture of one. It looks a lot like a circle.
We know who
On
Gutag
the
is
left is one with
repping
fewer
on
sides.
the vote.
And what he did is he then, since it was a polygon, he knew how to compute its area or its circumference, and he just counted things up. And he said, well, pi is somewhere between 223 over 71 and 22 over 7. And that turns out to actually, if you take the average of that, be a really good estimate. 2,000 years after Archimedes, the French mathematicians Buffon and Laplace proposed finding the value of pi using what we would today call a Monte Carlo simulation. They did not have a computer to execute this on.
They just do it by hand.
So what they proposed
Mike
started
Scratch.
with this mathematics. They took a circle
Okay.
and inscribed it in a square.
With 1 by 1
Square
radius.
of 2
With
units
a
of
diameter
whatever it is per
2.
side. And therefore, we know that the area of the square is 2 times 2, or 4.
Yeah.
We know that the area of the circle is pi r squared. And since we know that r is 1, because that's the square it's inscribed in, we know that the area of the circle is exactly
Did they try to solve for the white
pi.
space? Oh.
What Buffon then proposed...
So they said the area of the square is 2 times 2, which is 4, right? The area of the circle is pi r squared. With r squared being canceled out somehow by... So what's being... Okay, so what is being taken up by the square area and by the circle area, I think, is being determined by this r squared factor.
Proposed was dropping a bunch of needles at random. You know, kind of like when Professor Grimson was sorting things, and seeing where they land. Some would land in the square, but not in the circle. Some would land in the circle. You would ignore any that landed outside the square. And then they
back a
some
little bit.
bunch
Hold
of
up. I want to look at this
exact
again.
1, 2, or so mathematics.
This is really interesting.
So what they proposed
Okay.
started with this mathematics. They took a circle and inscribed it in a square of 2 units of whatever it is per side. And therefore, we know that the area of the square is 2 times 2, or 4. We know that the area of the circle is pi r squared. And since we know that r is 1, because that's the square it's inscribed in, we know that the area of the circle is exactly pi.
Okay, so they just factored it to a r of 1. Got you.
What Buffon then proposed was dropping a bunch of needles at random. You know, kind of like when Professor Grimson was sorting things.
Dropping a bunch of needles at random.
And seeing where they land. Some would land in the square, but not in the circle. Some would land in the circle. You would ignore any that landed outside the square.
Okay.
And then they said, well, since they're falling at random, the ratio of the needles in the circle to the needles in the square should exactly equal the area of the square over the area of the circle. Exactly, if you did an infinite number of needles. Does that make sense?
Oh.
Now,
wow.
given that, you can do some algebra and solve for the area of the circle.
So just use like a normal
And
distribution.
say it has to be the area of the square times the number of needles in the circle divided by the needles in the square. And since we know that the area of the circle is pi, that tells us that pi is going to equal 4 times the needles in the circle. That's 4 is the area of the square, divided by the number of needles in the square. And so the argument was you can just drop a bunch of these needles.
What? Dude, people are so smart.
Add them up,
Swear,
and
man.
from that you would magically now know the actual value.
Such a simple like thing, but it's so crazy that it solves so much.
We tried a simulation one year in class, but rather than using needles, we had an archer and we blindfolded him, so he would shoot arrows at random, and we would see where they ended up. There's a video of this here if you want to see it. I'm going to play only the very end of the video, which describes the results.
Maybe we should just use Python to build a Monte Carlo simulation instead.
So that's what happened. After it was all over, Anna came up and
That's so funny, actually. Yeah, that's such a good programmer joke.
Shot with the apple. I had hoped the student would put it on his or her head.
That's funny math joke.
That was not done blindfolded. Any rate, so here's the simulation.
Maybe we should do a Monty Python.
So first we have throwing the needles. For needles in range 1 to number of needles plus 1, we're going to choose a random x, a random y.
And circle 0. And then if it lands within the bounds of the circle,
it's in the circle, and there we'll use the Pythagorean theorem to tell us that. All right? And we'll just do this, and then we're going to return exactly the formula we saw in the previous slide. Now comes an interesting part. We need to get an estimate. So we start with the number of needles and the number of trials. For t in range number of trials, we'll get a guess by throwing number of needles. And then we'll append that guess to our list of estimates.
The number of trials for every trial.
We'll then compute the standard deviation.
We're going to estimate.
Get the current estimate, which will be the sum of the estimates divided by the len of the estimates, just the mean of the estimates.
Mean of them, okay.
And then we'll print it. All right? So given a number of needles and a number of
doing it
trials,
a bunch of times
we'll estimate pi, and we'll give you the standard deviation
of that estimate. So we're getting a sample on our population. We're averaging the means of the means.
However, to do that within a certain precision,
all coming together
I'm going to have yet another loop. And I'm showing you this because we often structure simulations this way. So what I have here is, well, the number of trials, which is not so interesting, but the precision. I'm saying I would like to know the value of pi, and I would like to have good reason to believe that the value you give me is within 0.005, in this case, of the true value. Okay. Or maybe more precisely, I would like to know with a confidence of 95% that the true value is within a certain range. So what this is going to do is it's just going to, I should have probably used 1.96 instead of 2, but oh well. It's just going to keep increasing the number of needles, doubling the number of needles, until it's confident about the estimate. Confident enough.
Until we reach a precision, okay.
All right, so this is a very common thing. We don't know how many needles we should need, so let's just start with some small number, and we'll keep going until we're good. All right, what happens when we run it? Well, we start with some estimates. When we had 1,000 needles, it told us that pi was 3.148, and standard deviation was 0.047, et cetera. So a couple of things to notice. One, are my estimates of pi getting monotonically better? You'd like to think as I add more needles, my estimates are getting more accurate. So that's question one. Are they getting more accurate? Not monotonically, right?
Well, this one was 1.5, then it
If
went
we
back.
look at it, where,
And then it
where
went
are
back
they
to
getting
1.415.
worse? Let's see.
So you're getting worse here,
3,
right?
all right, 3.148. Well, 3.13 is already worse, right? So I double the number of needles and I get a worse estimate. Now the trend is good, right? By the
Yeah,
time I
you kind
get
of overall
here,
trend
I've got a
upwards,
pretty
right?
good estimate.
But there isn't like,
So overall, as I
what does that
look
tell
at
us then?
larger samples, a bigger subset of the population,
I tend
my
to trend
estimates
towards the
are
right answer.
trending towards better, but not every time.
Because there is randomness.
On the other hand, let's look at the standard deviations. What we see here is that the standard
Getting
deviations
more and more
are
confident.
indeed getting monotonically better.
We're getting more and more
Now,
confident.
there's nothing mathematical guaranteeing that, right? Because there is randomness here.
Or our deviations
But I'm
between
increasing the number of needles
runs
by so
is-
much that it kind of overrides the bad luck of maybe getting a bad random set. And we see those are getting better. So the important thing to see here is not that I happen to get a better estimate, but that I know more about the estimate. I can have more confidence in the estimate
Yeah.
because it's closing in on it. So the moral here is it's not sufficient to produce a good answer. I've said this before. We need to have reason to believe that it is close to the right answer.
In this case, small standard deviation implies that we are close to.
So in this case, I'm using the standard deviation and say, given that it's gotten quite small,
No. I mean, it's
2
still
times
random, right?
1.96
You're doing it
times
randomly. You're not doing it.
0.002 is indeed a small number. I could make it smaller if I wanted. I believe that I have good reason to believe I'm close to the right value of pi. Everyone agree with that? Is that right? Not quite, actually. It would be nice if it were true, but it isn't. So let's look at some things. Is it correct to state that 95% of the time we run this simulation, we'll get an estimate of pi between these two values? I don't expect you to do the arithmetic in your head, but the answer is yes. So that is something we believe is true by the math we've been looking at for the last 2 lectures.
Okay.
Next statement. With a probability of 0.95, the actual value of pi is between these two things. Is that true?
I don't think so. It's not probability, it's confidence.
In fact, if I were to say with a probability of 1, the actual value is pi is between those two values, would it be true? Yes.
Yeah, okay.
So they're both true facts.
Okay.
However,
Oh, well, it says right.
only the first of these can be inferred from our simulation.
Yeah. Because
While the second fact is true, we can't infer it from the simulation.
Because there's randomness.
And to show you that, statistically valid is not the same as true. We'll look at this. I've introduced a bug in my simulation. I've replaced the 4 that we saw we needed by 2. You know, easy kind of mistake to make. And now if we go to the code,
Sorry, that was loud.
well, what do you think will happen if we go to the And what you'll see as it runs is that once again we're getting very nice confidence intervals,
Yeah.
but totally bogus values of pi.
Yeah.
All right. So the statistics can tell us something about how reproducible our simulation is, but not whether the simulation is an actually accurate model of reality.
Okay.
So what do you need to do? You need to do something like a sanity check. So here you might look at a polygon and say, well, clearly that's a totally wrong number. Something is wrong with my code.
To estimate the area of some region R.
Okay. So just to wrap up, what we've shown is a way to find pi. This is a generally useful technique to estimate the area of any region R.
Welcome in, man.
You pick an enclosing region, call it E, such that it's easy to estimate the area of E, and R lies within it. Pick some random sets of points within E. Let F be the fraction that fall within R, multiply E by F, and you're done. So this, for example, is a very common way to do integration. I promised you we'd talk about integration. So here's a sine of x. If I want to integrate the sine of x over some region, as done here, all I need to do is pick a bunch of random points, red and black in this case, and look at the ratio of one to the other. So showing how we can use randomness to, again, compute something that is not inherently random. This is a trick people use over and over and over again when confronted with some situation where it's not easy to solve for things mathematically. You just do a simulation, and if you do it right, you get a very good answer. All right, we'll move on to a different topic on Wednesday. Nice,
sweet. That was lecture 7 of MIT OpenCourseWare 6.0002, Introduction to Computational Thinking and Data Science from fall 2016. Like I said, that was lecture 7 on confidence intervals. So really kind of displaying, getting into like models of these types of simulations, and then understanding, distributions and applying some statistical distributions to these kinds of ideas in these models, right? So, and then getting into confidence to where you can find the area with under the curve, right? Would be the integral, right, of basically to find the probability that something would land within 2 points, and you can have confidence up to some certain standard deviation degree, right? So it's or something along those lines. It's still kind of a little bit fuzzy and whatnot, but I'm still trying to pick up, learn, and remember stuff from my college days, learning about this stuff more in depth. But now these are from fall 2016. I think probably a lot of material is probably still the same. I think a lot of these older classes, these introductory classes are probably the material is probably the same. A lot of stuff probably changes in the more advanced stuff, and probably with AI classes and things like. Probably more new classes are coming out rather than changing the older curriculum. I don't know, or else they probably wouldn't offer it, right, if it was kind of outdated maybe. But obviously it has to have some merit here. But awesome, cool. So I think what I'm going to do is, in some of my free time off stream, I'm going to go back through these PDFs and kind of, or this PDF, and just jot down some notes, because it was pretty dense and I didn't really want to just keep going back and forth and kind of getting behind on the video. I wanted to really focus on what he was talking about and go through the code. So I'll go back through the notes here and kind of jot down my Spark notes and what I think was important, and kind of get that out to you guys here shortly. But I am behind in the Discord. I do have a Discord here where I post, I have the CS50 course, CS50X. I have weekly breakdowns of all the weeks I did, week 0 all the way through week 9, where you can get like a breakdown. I use some cute emojis and whatnot to make it fun. but you can get kind of like a breakdown to of all the things I kind of learned, the things that were important. I kind of went through my notes and jotted down a bullet point for kind of each of the main things. So if you're interested in going through these weeks, then I also have just links to my GitHub repo for the notes, as well as each of the live streams we did to watch the lecture, because these ones were long, like 3 hours long, and then also the parts for solving the problem set for that week as well. So I have these breakdowns in my Discord if you like them as well, and I'm going to go back through and do them for the MIT as well. So bear with me. I will be going back through and doing this is just my introductional kind of slide here for the course, but I'll go back through and do weekly breakdowns of it all and everything in the Discord too. So I'm just behind. Bear with me. I have a full-time job as a chemist. I've been teaching myself how to code every single day, basically for the past year, trying to learn as much as I can and just practice. And so, yeah, this was Lecture 7, Confidence Intervals from MIT OpenCourseware of the Fall 2016 MIT 60002 Introduction to Computational Thinking and Data Science. Cool. All right, I'm going to wrap up the recording here with a wave. Thanks, guys, for watching on the recording. If you guys would like to check the live stream, make sure to join the live streams so you can watch these lectures live with me if you're watching the recorded version back on the channel. And yeah, all right, cool. That ended the recording. Nice. One more done, boys. One more week done. We're moving on. I think we have to do a problem set after the next lecture. So these problem sets, they're starting to ramp up quicker now. So there are not as many lectures in between the problem sets anymore. But the problem sets are getting harder. And I can tell this next one might be even more difficult. So on the last one, we had to go into their code base, which had some pre-written objects for, what was it? What was it? I can't believe I forgot already. Oh yeah, like nodes on a graph with weights, like traversing like a path, basically, find like the shortest path. We implemented a DFS algorithm using these custom objects, which was a little bit more difficult than just a basic LeetCode DFS because we really had to use some of these and learn some of these pre-existing methods and how they worked. They hashed the nodes into the digraph with with as the keys using hash values, and so that's how you were able to detect them. We also found a bug in their source code that kind of made things a little bit tricky that we had to work around, but yeah, so you guys can go back through and watch that if you guys are interested. But we're gonna keep going on with the course in the problem set 3 next, I believe. So let's check out the syllabus here. So we just finished confidence intervals. We can do problem set 3, or we could watch the sampling error. We can do either or next, but we can't move on to 9 until we finish both the lecture 8 and problem set 3, because problem set 3 is due on lecture 8. So I'm assuming that you have problem set 3 due the morning of the lecture, right? Typically, but I'm giving myself a little bit of leeway here. We just say that, okay, we have to clear out the entire line item before we can move to the next week. So we do have back-to-back weeks of lecture and problem sets here. So tough luck on us. But then we start getting into machine learning, you guys. So this is going to be big. I've been wanting to get into this. I feel like this is the direction kind of modern society is going. So this is going to be huge to kind of actually maybe start progressing further down into more actually application of our programming into more real world scenarios rather than just our little side projects. We applied to programming roles. Yeah, I had one job interview, just one, that I didn't do too good on, dude. I was so nervous. I had one, it was a software engineer chemist position. They didn't ask me a single chemistry question or physical science related question. They honestly just wanted an advanced scripters, honestly, and I just wasn't up to their standards. So dude, I was so nervous. I was like puking right before. Like I do not do well with coding in front of people like a lot. Like I do it all the time here on the stream, but it was just I don't know. I just psyched myself out. I think I just got really, really juiced up out of it. Anyways, cool. Super stoked to be moving on with the course here. I wanted to show you guys our script really quick before I walk off for today. I've had quite a busy week at work, so I think I'm gonna might call it a little bit shorter today because we did do a longer stream yesterday, doing some coding and debugging on our project. So this is our current project that we're working on right now, which is a scraper script. So I'm writing a scraper script which will go through me and my girlfriend's small business, our Depop, which is where we sell our products. It goes through that site and scrapes the information from there. So then I can try to update like automatically like sales and whatnot and try to. But the main goal is so I can feed through a main kind of website. I'm going to build a website for the business, and then rather than having checkouts and carts and stuff on my website, because I don't really care about doing all that stuff. When I have a service that kind of does it all for me really nicely on Depop, and that has like the customer base already for vintage clothing. So I'm just going to scrape the one-to-one information off the Depop and then feed basically customers from the website to the Depop to make sales and make purchases. So that is my goal, and then is to try to like actually make a cool kind of modern site that has some like artsy vintage look to it to kind of build this out. I think is really cool. So that's the goal for this. But so this is the script we've been working on over the past day or so, where let me just run this for you guys and let me show you guys what happens here. Bum-ba-da. So it goes to the Depop page. It goes through all of the rows. I'm printing out the page height here so I can kind of. I was tailoring off stream yesterday the page the page scrolling because I need to lazily load all of these items so I don't miss any. So I was trying to figure out the timings and the fastest way I could scroll the page without missing or skipping renders. And then I kind of put a hard stop on this. I put a hard stop on this opening of additional pages, right, on the actual product, so we don't, I don't have to go through and break the loop myself and Control C or whatnot. So let me show you guys one more time what's happening, and I'll explain it. So we run the program, it opens up our page and starts scrolling our page. So then it can start, and while it's scrolling, it's loading all of the content to the page, right? It's getting everything rendered out. It gets to the bottom of the page, realizes that there's no more, heights to move down, right? So this it's complete, and then it goes ahead and scrapes the product URL. So as you can see from data.txt that was rendered and saved here, these are all of those product URLs that we scraped from the HTML, right? Using Playwright here. So then it goes through and actually opens up each one of these URLs in a new page, basically, and then closes it right away. So my goal here is to actually, have the page open because we need to then, not only do we need to open the product, we need to parse the product from there, get the images, get the description, the title, the pricings, the size, all that jazz is on the actual product page itself. So I'll run it one more time so you guys can see it here. It opens the site, starts scrolling down at a rate that can keep up with the loading. So as you can see, we're getting all of the items. There's nothing being skipped over. Everything's being able to load in time. Boom, we get to the bottom of the page here. Boom, and then it opens up a couple of these and then closes them because I just have this hard close here. Right. So that is the project so far. My next goal for tomorrow, what we'll do is, or if I decide to do some coding off stream later tonight, because I usually get like a second wind around like 10:30 at night to start coding again. But what I'll do is tomorrow we will write the actual part where we go into this page that we've opened up for each of the individual products, and then we will go ahead and write the parser for that. So let me just kind of, I guess I could. Let me do this. Okay, so if I go to inspect here, let's click on an item. Okay, so I got my hover tool. Okay. So this has images. Here's an image. So we don't want to just grab all images. We need to grab. So this is how I did this last time. Is what I did is I just inspected the page, and I went through and found the content I was looking for and just isolated that with some functions. So this is the class H1 Bebes 19. Right, okay. Styles title underscore. Okay, that's an H1. This is a paragraph. This is also a paragraph with the text Bebes 41, styles price, H8QD4, QDH. So do all of these have text Bebes 41? Yeah, they do. Like this. Okay, so we don't want to go off that. We don't want to grab that. So we're gonna have to grab styles title, KWCG1. And then this is styles prices. Oh, so this is styles current price. Original price. And then you can get the paragraph within that. Okay, easy. And then these are styles image container. Oh, easy. Oh, let's go. This might not be that hard then. Maybe I'll just code for a second here. Okay, so let's see here. Let me open up let me get some tunes going here. Okay, so let's just see what we can do. Okay, so we await the product page, and then we close, so cool. Okay, so right here, we need to parse product page and extract the following, right? We're going to get the product images. We're going to get the product title. Let's just do this product. Let's do title, description, current price, or say price plus fee. We'll say price with fee. Say listing price. And then we need a size. And then a status. Strike, gang. Okay, so the title of this page styles so they have a carousel container, so mobile view, desktop view. Gotcha. So this is going to be a desktop view. Okay, so we have a couple of containers. What is this? That's that image. So then, okay, so these are all just the images here. And then you have a styles container. There's a button. Okay. So we want desktop view here. Don't give me desktop view. Okay, so then let's hover on title. Let's just try to grab a title. Let's start with that. So this is in the styles product info GNH1M class. Okay, copy. So if I go here. Okay, so let's just say, let me come here. Styles, product, info, H1M. Scrape up, chill. Okay, styles, product, info here. So we're gonna grab this container. So this is the container that owns this. So the title is gonna be this. So styles underscore title underscore underscore KWCG1. Right? Okay, so let's do this. Let's see what we can do. Okay, so we're gonna say await page await, page dot wait for selector. We're gonna do a selector string of this, right? So do I have to say div dot? Because it's a class applied to the div. And this is an h1 dot, right? With that style applied to it. So we wait for this page. Okay. Now this is going to return us back the content container, right? We can say so then I can say title equals to content container, or we'll say await content container dot query selector. And we're going to do quote returns when element specified option. We don't save that. So we just load it, and then we'll go to on this page and get query selector for the H1 styles here for the header. That's going to get the product object. Oh, hold on, let's do this. Let's await. Let's do page dot query selector. We'll say product content equals to this product info. We'll say product info to match the class product info. Then we'll go into product info and query get attribute of this. And then let's print title. See if this works. Come on. Show me the money! Show me the money. Let's see if it works. Come on. Come on, baby. Get to the bottom of the page, open up the things. Shoot. Ah, dang it. Broken. Okay, so we wait for the selector of this style div.styles product info. And then we go to product info is equal to, we query that selector. So let me say, let me print here. We'll say, let's print here. We'll say, info found. And then we'll print, if we're not getting the title. We're even getting that. Come on, baby. It's so cool, it does it on its own. It's kind of magic. It's magic! Oh, 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 it's magic, you know. No. Okay. Okay, so it's not even finding the product, so this isn't happening. So we query, wait for selector. we query for the selector. Why isn't this working? So this is the title here. Why aren't we getting... Let me get rid of the div. Well, I don't, it just takes too long to load, so hold on, let me see here. So wait for this. We won't do this. Wait. Product info found. Okay, title. We go page.get attribute. So what if we say probably query selector for this equals title element. So it returns back the element, and then we need to go into the title element. Right. Element dot text content, which is a function. Now can we print the title here? All right, let's try it. Come on, baby. No. So product URLs over the title. We wait for the selector. Print product info found. It's not getting the selector. Am I spelling it right? STYLES underscore PRODUCT capital INFO underscore underscore capital GNH1M. Yeah, that's what I had earlier, though, I thought. That's what I had earlier in terms of product. Product info equals page query selector. product info. Wait for some. You say await. Yeah, so page, wait for selector on the div. You wait for that selector to load. Then you query that selector for the product info. Then you say get attribute. So you product info dot query selector for this guy. Let me have title element, right, equals, let me say title equals wait title element dot text content. You just print title. So this opens the product URL, prints that it's opened. Print locating product I of length. Locating product info, one of product information. Okay, product info found. So this is locating 0 of 20, 200. So I can't, it's not finding the div. The same thing. Okay, I'm gonna try this little thing. So it might be the hash that's not working that comes after this thing here. So if I just put this, right, I have this thing here. Let's see if we get it now. Oh, I think this cookies thing, it might be messing us up. It might be that. Is it the cookies thing? I don't know. Styles.product info, here it is. Making sense. Shouldn't matter. Wait for select. This. Let's check if it exists all. So right before you do the Hmm. It's not finding the div container for some reason. Oh, rip. What happened to the stream? My bad. Okay. Huh. Is this the HTML I was given? This is really long. Okay, I wrote the HTML to text and Command F for the div, and it's not there. The initial HTML loads without that div. JavaScript fetches additional information and renders them dynamically. Instead of dumping HTML immediately, wait for specifically for that element after JavaScript renders it. So what it says, I am waiting and I guess it never comes. This is my just like a bunch of code. Just a bunch of code like so. Let's go 4 frame. What will this do? This is a blank. It's only frames by reporting. Add this. Let's try to do this. If we wait until the document fully loads, potentially. Alright. I'm not sure what's going on. Do you have any ideas? It's mate. Styles container. Styles. Product. What happens if I accept that cookie? What if I accept? Yeah, it's not. Get it. The divs are there on headful inspect and are loaded right away. So hold on, if we have to like so this will that will hit the cookie for us. Expand all this. Styles, product info. Let's see what he has to say about this. This image. don't get how this isn't what I'm supposed to really be using a page instead of one. Oh, come on, Mike. Product page. Let's see if we get it. Okay, let's see if we get it here. Come on. Come on, baby, show me the money. I'm probably getting off after this one, though. We're at 2 hours. I'm done, you guys. We can always try again tomorrow. Oh, we got it. Yes! Yes, yes, yes! Yes! Woo! We got it. Okay, we got it. Let's go. Delete. We got it. We got it. We got it. We got it. Let's go. Okay, so let's see. Products. So I'm just gonna get. Hold on. So I'm gonna get this styles product MFDIO. Yeah, that's what I got. Okay. And then out of here, I extracted out the title. Oh, let's go! I'm so stoked. Okay. So watch this. All right, let's do this. Hype now. Let's go. That's so cool. Okay, so we need to do this then. We got some code to write here, boys. We got some code to write real quick. So let's go. Okay. So let's go touch product dot py, and then we'll code okay. We're going to create a class called a product, which is going to be defined with an init, and we're going to have a title, which is going to be a stir. We're going to have description, which is a stir. We're going to have listing. Oh, I already have this listing. I'm stupid. I'm so dumb. I already did this. I already did this. Okay. Okay, we're gonna go like this. From server oh. Come on. So I'm gonna rename this to product. From how do you do this? Or in scripts. From this directory, no. From server. Ah, there we go. Okay. Okay. Title subpraise. Why is it doing this? Why is it doing this? Why isn't that working? Huh. I should say import server. I don't even have a main. What's a new server? Oh. Run it from the root directory. Ah, it's just so frustrating. Put the script in the server. don't know how to do this. In the same directory. Server. So from this folder. From objects import. Oh yeah, I suck at importing stuff. I'm trying to import from in my scripts, depop scrape here. From dot objects dot listing import listing. From objects dot listing import listing. From dot objects or slash objects, dude, I don't even know. Object. From server. I just want to import this listing. Okay, so this does not. I'm in server. No, dude. Alright, whatever. This is annoying. Okay, so I'm in debug script. Here we go. God, I hate these imports. I think that I'm clearly missing some information regarding imports, but that's how. Okay, I got it here. New listing, there's title, sub price. Title. Okay, I'll go for just like 3 more minutes, you guys, and then I'm gonna call it. I'm tired. Okay, so let's just quickly grab the description. See if we can grab that guy. So the description is styles container. Okay, so now we're going to get a paragraph. It's all of this. So for the description element, is equal to await info dot query selector or this. Description equals to await element dot print. See if that works. I'll get the div that holds the description. Then, okay, so let me grab the div oh, this is p dot. For this guy, we say, this is the product. Title is this guy, h1.styles title. Okay, so then we want to await an element description. This guy right here. Take this. Paragraph dot. This. Right. Working. Oh, we got it. We got it. Let's go. Yes. Yes. All right, we got the description. Let's go. Oh, that's tight. Nice. Okay. Got the description. Now can we get the price with the fee? So, so what do they call it? So they say, place with fee. subprice. What is the wrapper for subprice? So they're both styled the same then, actually. So I might need to go to this div here. Okay, so we'll say chroma selector. Let's say total price element. Let's say div. Say all right, let's see if that works. Let's see if that works. Oh, it's not, it's a P, it's a paragraph. Ooh. Imagine commenting that on a random person's stream. L. L rando. We don't want the anchor tag, we want a paragraph tag. One sec. Okay, good, that didn't show any numbers. Just showed some spammers, that's fine. Open up the FaceTime, made sure there wasn't any Okay, it's interesting how that won't work out here. All right. Let's see if we got this. Let's see if we got this. I think we got it here. We get pricing. Yes! Look at that! Look at that! Woo! Yes! Let's go! Nice! That's so cool! I'm hyped. Let's go! Okay. We're almost there. We'll just try to do the size. I'll try to wrap this up. I know I said I'll be done, but I'm having fun. So we'll do the size now. So we'll do size element is equal to await product info dot query selector for, let's grab the size element now. So this is a size small. Okay, so query by selector. Size div. Size condition brand, okay. Ooh. The size condition brand div equals to this. Subprice element, we'll say size element equals to await this div query select for p dot they don't distinguish these. They have the same class. They don't distinguish these with an ID or anything either. So we have to go by query select all, right? And then what we'll do is we'll say this, all paragraph tags. We'll say p tags we'll say for paragraph in p tag, right? If paragraph dot starts, gonna do that. No, we have to do if paragraph dot. If we slice the paragraph up to the fourth character equals to quote size, we're going to save this. We're going to say size equals to none, condition equals to none, well, size is always listed before condition, so maybe we could just say p tag index of 0 dot text content, and then we can say p tag index of 1 dot text content. Now let's print size, and let's print the condition. Hey Mike Funk, yo yo yo, SS Low, what's going on, my dude? Okay. I think we got it. It wasn't erroring out, it was still loading the things, so I think it'll work here. Come on! Come on, boys! We're getting a lot done here. Size S, excellent condition. Yes! Let's go. All right, almost there. Okay, so now we just need to get size. Brand. So this one's going to be brand equals to brand element equals to we're gonna go brand equals to size condition brand div dot, we'll say await dot query selector for the anchor tag that's in here. Wait, it's an anchor tag. Yep. And we're gonna get that brand element. Let me say brand equals to brand element dot text content. I'm going to print the brand. Okay, and then we don't have a type. It's here. Tanks, tops, and camis. Hey controller, I love your streams a lot. Keep up the great work. What other programming language do you know except Python? I'm mainly just a Python loser. I'm a data scientist, or a scientist in general that likes data, I guess. I'm a chemist, and so Python's really helpful for that. So that's why I kind of been learning it. But I know a little bit of React HTML, CSS, barely any JavaScript. I know a little bit of C from just some of the courses I've taken, but honestly, I wouldn't say I know. Like, I would say I know of. Okay. Okay, so we're gonna get this styles container, and we're gonna get take the last one. Okay, so what we'll do is this. Okay, so what we're going to do is this. I'm going to go into here. So we need to write for, we're getting the brand, now we get, I don't have a status thing on here, so that's fine. We just need the clothing type, right? And then we'll be done. So we just need to say, we'll say, clothing type, whatever element, is equal to the product info, or actually, okay, so it's in the product info. Oh, maybe not, no. It's in the page. So it's on the page. It's in this thing here. And we're gonna query for all the line items in here. And then we're gonna query for all the line items in here and take the last one. Okay, I think I want this. I think this is unique. Text OTH. Is this tops also a label? No, it's a text OTH as well. So this label, this is the only one with this label. So I'm gonna go here, equals to page dot query selector for paragraph dot this. And then let me say clothing type equals to clothing type element dot text. All right, let's try it. If you guys are here right now, I appreciate it so much if you guys could leave a like. It's completely free. It's the one thing I ask, please, if you guys could. I've been streaming for 2 hours and 45 minutes. I went an extra 45 minutes for you guys. So if the 13 of you guys that are in here could leave a like, it would mean a lot. It's just a small ask. Thank you guys so much. Okay, so then we need to get the div. We're going to take this div that contains all of this, and we're going to query for all. We're going to UL this and query for all the line items. We're going to take the UL. Okay, what we'll do is we will say this, but we'll say UL dot this, right? UL this. We're going to say clothing type element dot query selector all for the quote line item, right? We're going to say this is the clothing type div, right? Then we're going to say is equal to the clothing type div dot selector for all the line items. We're going to select clothing type div element index of -1 is equal to we'll override it, and then we'll get the text content of that value. Did we get the brand? No, we didn't. We got a coroutine. Let's do this. Come on, last thing we need here. Found this guy, the UL. So the line item RSDFV then we'll get the last one of those, and then the text content of that. Come on. We gather the UL, and then we got every line item in there. That's why. I think that'll do it. I think we found it. Come on, show me the money. Oh. None type. Clothing type almost none. Huh. Am I even? Saying product page is this. Query select all. We'll query select for all of the line items that have that tag then, whatever. Why is it not working? We are finding it. It's not finding any line items. In the wrapper. So it's returning true for this. Let me see if I can do it for this container. Let me do this really quickly. I'm gonna bypass this for right now. I'm gonna say product URLs. Trying to see if we get this container. So trim. So it says none for this wrapper. Interesting. So I can get this guy, but I can't get this guy. Huh. I can get and I can't just query select all of these. see, I get true for the parent div, but when I look inside, it's none. Why won't this grab these line items? Why is it always the last thing? So what happens if I just get select all paragraph tags, right, in this wrapper? Like what if I pink and purple vest can So if we say, let's just query select all paragraph tags that are in this wrapper here. Styles container ultimate. Else. This is my last attempt here, and then I'm calling it for today. I've been going way too long. 3-hour stream today, you guys. We getting all of the paragraph tags. We're not getting any clothing type elements. Because it's not hitting here, clothing type element, paragraph, it's not working. I don't get it. Crazy, Oh, yeah, I can't figure it out. We get the wrapper. How can I print? Okay, one more attempt here. Let's see what this does. Loading. Loading. Dot dot dot. Hmm. All right, I'm just gonna take what it says here just for now and see if it even works. If it doesn't, then we're moving. Then we'll have to try something else. But I just want to see what it even does here. Okay, so we're getting product. Huh. Interesting. I can't figure out the clothing type. The last thing I need. I don't know why it's not. This list. Why is it not taking this UL? Come on. So then we say Li equals to await UL query selector for the Li element that is inside here. See if we can get this Li element. I just wish this first part wasn't so long. I might need to write something to pull it off of the file. Why is it doing a none type? So if UL is giving none, I'm getting the home now. Okay, so I say await for the selector with a timeout. If UL, we query for all if line item. I think we might have got it. What did it do differently? Just this timeout? Did you need some time? Huh. This was giving me the home. get it. How did it do it? I swear I did this. I swear I did this. I did this. All right, last go here. I think we got it. I wrote this same exact line and it wasn't working. I swear I wrote this. I swear I wrote this. Except maybe this time out, but maybe that was it. Yeah, there it is. It works. Shirts. T-shirts. Shirts. So this is printing brand twice sometimes. Why? $12. Like mud clothing got printed twice here. Let's try it one more time here. So sometimes it's giving us the brand twice, and I only have one call to print the brand. Like that, Rampage twice, American Vintage twice. Hmm. Why would some of our brands be twice? So why is it printing Old Navy twice? We have one call to brand. So let me do this. Let me take out total price, description, title, subprice, size, condition, brand, or you wait for the selector to appear first. Okay, so then if we go here and create a listing and call subprice equals subprice, total price equals total price, size equals size, condition, brand, description, and clothing type. And then what we'll do is we'll print just here the listing. And then, so I'll go to my listing here, and I'll just quickly write a def dunder stir given self, which is going to return going to print dunder return return we'll say self dot title, so self dot, and then we'll do a \n self dot title, self dot subprice, self dot total price, self dot size, self dot condition, self dot brand, self dot description, self dot clothing type. Almost there. All right, last run here. Come on. Come on. Speak now, or forever hold your peace. Hey BK, how's it going, dude? Yeah, we're scraping this website trying to extract out the product information from each product. We're getting the URL by going through and loading each product and then going and clicking on each URL and extracting out info. Ooh. Okay, so price. Okay, so we'll slice off the first on the prices. So sub price. And we'll do sub price, slice up through the first character forward, and same with total price, because that's a dollar sign there. All right, one more run. Come on. Gosh, so many runs. I'm tired. I'm done, dude. It's 10, 11 o'clock. I've been coding for 3 hours and 40 minutes. Two open, boom. Product 3 of 260, locating, boom. 4 of 260, 5 of 260, 6 of 260, 7 of 260, 8 of 260, 9 of 260. All right, let's see. All right, let's see what we got. Everything look good? 1 of 260. Description, price, size, excellent, condition, ramp, brand, description, tanks, tops, and cami. Oh, nice. Let me go to the listing really quick, and let me just put title, and let me put sub price, let me put total price, right, and let me put size, let me put condition, let me put brand, let me put description, and then let me put type. All right, one more time. All right, and then also let me put a /n here. All right, one last time for the giggles. Come on, boys. One last time. Come on, for the giggles. We're parsing the page. We are getting all the URLs of all products. We are then going through and opening every URL of the product in a new page. Boom. And we're extracting out the info. Boom. Product 2. Yes. Yay. Woo. Yeah. Woo. Feels good. Leave a like, you guys. Leave a like. It's working. It's working. We got it. All right. This is the script. Now we can just add additional things if we want to parse out. So something we will have to parse out and add on here potentially is just a indicator to identify if it's sold or available. Right? And so we might be able to speed this process up for that indicator, because if you reach a sold product, every other product from then on out is sold already, because it goes in order of available to sold. So once you hit a sold product, we can just take that index and mark all the rest sold and then move forward from there, if we want to add that as a part of our Yes, let's go. Look at it going. Look at this little bot moving. All right, All right, so these were our returns. So we loaded product 1. Boom. Product 2 loaded up. Product info was found. Boom. Product 3. Boom. Yeah, let's go. Woohoo. Nice. All right, you guys. Woo! What a stream. So we started the stream by watching the next lecture in the MIT 6.0002 course we're taking right now, which is free online through MIT OpenCourseWare. I highly encourage you guys to take that alongside of us. Where are you storing it in Excel? I'm not storing it yet anywhere. We're just doing the parsing. The only thing I am storing right now are those links that I had to store initially from doing that initial parse, the scroll. I get the links from the page, and then I open up every link and get the data from every product. So that's the only thing I'm currently saving at the moment, but I will be creating like a database to store the information in, and and then relay that somewhere. So yeah, this is just the first step here. But nice, we got that going. So now we can go ahead and add I will go ahead and add on to the listing a status, right? So a status could either be sold or available, and so we'll do that detection tomorrow. We'll write that detection. Oh, nice, nice. Let's go. Woo! Hey, BK, thanks for joining me here, dude. Yeah, so we'll write the status detection tomorrow for sold or available. That one will be pretty easy because once we hit sold, everything from then on is sold in the list. But we'll put parse, or we'll say scrape successful. We'll say scrape product pages. All right, cool. Look at that, you guys. All right, one more time for those that are just rolling in here. We have written our program to where it will go ahead and run. It'll open up our Birdie Rose Close website on Depop. It'll scroll through to preload and render out all of the content to the page through its lazy loading. So you actually have to scroll to get the content to load. Right, there it goes. Now we have gotten the URLs of all the products now that they're all loaded and we've saved them. And now we are going back through those products and opening them up and extracting out all of the information from the title, the pricings, the size, the condition, the brand, and the type of clothing item it is categorized in Depop. So that's pretty cool. Next thing we're going to do is also we need to grab the images. I've been learning and building in Python scripts and programs for a little over a year now, teaching myself through various courses like Python Crash Course, MIT OpenCourseWare, Harvard CS50. We've taken Harvard CS50X and P, and various books like DSA in Python, Fluent Python, Python Crash Course, and Python and Machine Learning. Hopefully soon we have that book too that we're going to get into. Yeah, so cool. Look at it go. Look at it go. Woohoo! All right, so plan for tomorrow, you guys. If you guys are new here, make sure you guys subscribe. We're almost at 2,850. We crossed 2,800 yesterday, so we've gained almost 50 subs in one day. So thank you guys so much. That is crazy work. You guys are really showing the love. Thank you guys. You guys are awesome. I love connecting and networking with you guys and meeting all you new folks. I stream every single day after my 9 to 5 job as a chemist. I have a degree in human biology and a minor in chemistry, and I work as a formulation chemist for a biotech company where I manufacture biological controls from scratch. And I kind of oh, what happened here? Hmm. So number 44 out of 260. which is a oh, this didn't get all of our products. Usually it does. I thought I got the timings right. I thought I got the timings right. $284. Interesting. Just started a few days ago. Nice, Jamie. What you been learning? What's your kind of goals? That's awesome, dude. Let me kind of let this run here. I want to see. That one has a brand. That one has a brand. Brand. Yes. 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 American Vintage. American Vintage. Old Navy. American Vintage. Banana Republic. American Vintage. American Vintage 23, 24, 25, 26. Yeah, my LinkedIn, you can find it on my website, michaeldeming.com, in my like socials area. Yeah. 32 American Vintage, 33 American Vintage, 34 Abercrombie and Fitch, 35. I think it was 44, wasn't it? 44 and 45. American Vintage, BB, Gas, Forever 21, American Vintage, American Vintage, Abercrombie and Fitch. Ah, yeah, so that didn't have a brand. So we do need to add some safeties into here. We do need to add some safeties into here to make sure that we, if the items don't have a brand or whatever, if there's missing information, then that's interesting. Let me go here. Which one was it? It was right before, right after the Abercrombie and Fitch striped mini skirt, line item 44. Here, Abercrombie and Fitch striped mini skirt. So that has no brand. That has a brand. Now here, this guy has no brand. And so this was left off of the DOM. Okay, so we'll need to bake in some protections to find these, and if they're not there, use some if or else statements then to move on. Okay, that's fine. That's easy. All right, cool. So tomorrow, you guys, tomorrow what we'll do is we will write the status indicator for sold or available, and then we will also get the images, and then we'll start adding some protections saying if that doesn't have a brand, right, then don't do it. If it doesn't have a condition, then don't do it. Else like none, right? So, all right, you guys, thanks so much for being here and joining me today. I'll see you guys tomorrow. You guys have a great rest of your evening, and I'll see you guys then. Bye, guys. Have a good one. Today was an awesome long stream, 3 hours and 55 minutes. So please, if you're here, honestly, it's completely free. It really helps me on a personal level with YouTube if you guys just hit a like on the screen. It's completely free. I don't charge anything. I don't even push for donos on these streams. I barely even do the monetization sometimes for y'all. So I keep it pretty chill and very very free and fair. So if you guys could hit the like, I appreciate it. Thank you guys so much for joining me here. Hey, keep cool. Sorry, dude, I'm just about bailing. I streamed for 3 hours and 55 minutes, so you had plenty of time to come in. My bad, dude. Sorry, dude. I'm bouncing. All right, you guys. We got a lot of this, a big chunk of this done today. So nice, feeling good. All right, you guys, thanks so much for being here and hanging out with me. I'll see you guys tomorrow. You guys have a great rest of your evening, and I'll see you guys then. Bye, guys. Here, I'll say bye to the pup. Come here. Come here. Come here. Say goodbye to the pup. Say bye to the pup. Bye.